there and welcome back again, and in this lesson we are going to draw the tangent function. Now, just like our previous two examples, our y can also be expressed as a letter with the x in brackets, for example fx, and please remember that is the same thing as a y, okay? And then we have a tangent x plus q, where the plus q, or if it was a minus q, it will simply tell us whether the tangent function moved up or down. Now, I'm not referring to this a. In our previous two functions, that was called the amplitude, but a tangent function does not have an amplitude, but it can have a value there, and I'll show you later what that value does, okay? So the tangent function is a little bit different from our other functions, as you can see. So a tangent function has a period of 180 degrees. This means that it takes 180 degrees for an entire cycle to complete, not 360. So it completes itself in 180 degrees. So if we have 360 degrees on x-axis, then it will complete itself 2 times. On this axis, we go all the way up to 180, so it will just complete itself once. Okay, now, again, a tangent function has 2 shapes. For a positive tangent function, it looks like this. If that is the line that we can draw right in the middle of these two, then it goes from that point upwards, and then it goes downwards. And you'll see that this is a dotted line. We call that dotted line an asymptote, because at 90 degrees, and also at 270 degrees, we don't have a tangent function, okay? It's undefined. A tangent function does not have a value for 90 degrees, and you can test that on your calculator. You can type in the tangent of 90 degrees and your calculator will tell you that it's an error. So what we basically know is that there is no values for the tangent of 90 degrees. So we have an asymptote there, and I'll also show you how we will draw it later on. Now, when we have a negative tangent function, okay, basically it's just the starting point, and then we go down first, then we have our asymptote, and then we go up towards the asymptote again. Now, an asymptote is a line which the graph cannot cross, because it cannot touch that asymptote because it's on 90 and there is no value for a tangent function at 90. Now, a minimum value, a tangent does not have a minimum value. It goes as low as minus infinity. A maximum value, it keeps going up, up to infinity. It does not have an amplitude, but it does have a range, okay? And the range is simply expressed as the following. We'll simply say y is an element of, the lowest point is minus negative infinity or minus infinity, and it goes up to positive infinity, and that will be the range. The domain, depending on how far we want you to draw it. If it's like this, we will simply say x is an element of 0 degrees to 180. Okay, and in this 0 to 180, which is one period, it will complete itself only once. I'll show you later on in the video what we do if we want to draw from 0 to 360, which is possible. It's just going to be done twice, okay? So this cycle is just going to complete or repeat itself once more, and I'll show you what that looks like later. So let's quickly have a look at our normal tangent function, which is y equals the tangent of x. Now, if I simply just go and draw that in, and I'll show you later how you can do it, but this is what it will look like, okay? So at 90 degrees, we have our asymptote, and can you see this line will not cross it? Okay, it goes up towards it, and this one comes down towards that line. Let me just put that on 180. There we go. That's what it's supposed to look like. So a normal tangent function always starts at the origin. And again, that's quite important to remember, because if it does not start at the origin, we know that it moved up or down. Okay, great. Now, if I go and I plus 1 here, okay, so it's q is a 1, so it's plus 1, so plus 1 there. This entire graph will move 1 place up, and it will look like that. Got it? Okay, and now let's see what it looks like if we minus 1. So then the whole graph will move 1 place down. Okay, as easy as that. And if we plus 2 from its original position, it just moves 2 units up, and that is what it will look like. Got it? And now we can also look at the influence of this value here at the front, that a. We know that that a is not the amplitude because a tangent function does not have an amplitude, but it must mean something. Well, that value tells us if we have an original tangent function, that value tells us the y value when we are at 45 degrees on our x-axis. So look very closely. I just want to move this so that everything is in line. There we go. So if I go to 45 and I go up to the y value, I'm right there. And I'll quickly make a dot there with my blue pen. And there we go, a nice little big one. And can you see at 45 degrees that y value is a 1? And that is the value here at the front of the tangent function. Okay, great. The same will be here at 135. It will just be a -1. Okay, so that is what that value means. Now, if I remove all of this, I'll quickly show you if we change this function to 2 tangent x. Now, if it's 2 tangent x, then basically our function will look like this. And if we compare it with our previous one, look at how steep the line, the blue line goes now, okay? And I'll quickly show you what I mean with that value in front of the tangent function. Now it's a 2, so at 45 degrees, it must be a 2. And look, all the way up, and I'll do this one in red for you. So we go all the way up, there we go. If the x value is 45, the y must be a 2, the same as that value at the front. So if it's not the same at 45, we know that the graph moved up. But there's a nice easy way, because a normal tangent function always starts at the origin. If it doesn't, it moved up or down. Okay, so basically if I move this one there, we know that it moved one place up. Got it? Brilliant. Okay, so that is all there is to this graph. And if I really want to go and I want to change this 2 to a -2, let's change it to a -2, and I'll quickly show you what this graph looks like then. Remember, now the shape is going to change to that shape where we won't go up first, we will come down first. So keep your eyes on this graph, and then it will basically look like this. And I'll just put it there in correctly, and there we go. So again, now it's a -2 at 45, it will be a -2. We start at the origin and we're going down towards the asymptote, and we're going up towards the asymptote, and that starting point will always be in line with the 180. Okay, got it? Brilliant. Now let's go and see how we can do this with our calculator. Now we are going to draw the tangent function, and this should also not be hard because your calculator gives you the plotting points. Now you just have to remember the tangent function shape, okay? So important. What does the shape look like when the tangent function is positive? What does the shape look like when the tangent function is negative? Make sure your y-axis and x-axis spacing are correct. And you can use steps of 15, 30 or 45 degrees. The smaller your steps, the more coordinate points you will have. So those are the 3 that's available to you. Now let's just look at what they give us. Fx is equal to 2 tangent x. Okay, and x is an element of 0 degrees to 360 degrees. Now they want you to draw the graph from 0 degrees all the way to 360 degrees. Okay, I know that the tangent function has a period of 180. So the first cycle will complete itself up to 180. Then after that, the cycle just repeats itself, okay? And you can just type into your calculator when they ask you, the starting point is at 0, and we want you to draw it all the way to 360, so the end will be 360. Even though the period is 180, you are just going to have 2 cycles in this domain, okay? Got it? So let's see how we will do that on our calculator. So if I open up the calculator here, please pay attention. So we press the mode button, press 3 to access the table mode or the trigonometry function mode. Then you press in 2 tangent alpha x, close the bracket, press equal, and then there's no gx, press equal again, start at 0, press equal, and then end at 360 degrees. And then we choose our step. which is 45 degrees for a tangent function, and then we can pause right there. Okay, so now let's plot our points quickly. Now our first x value is 0 and the y is 0. So 0 and 0 is right there. So let's quickly draw that in, and there is my dot. Okay, brilliant. Now, how about this second coordinate point? 45 and 2. So there's our 45 degrees. There's 2. Let's plot that point as well. There it is. Okay, brilliant. And that is true because that value is a 2 at the front. And we know that value for a tangent function tells us the value at 45 degrees. There we go. When it is a normal function, it didn't move up and down. Okay, so that value tells us what the y value will be at 45 degrees when our function did not move up or down. Now 90 degrees is an error, so at 90 degrees I must draw in this asymptote. So you have a ruler, so you can do it nice and straight. I'll do my best here, and there we go, and we go all the way down because an asymptote is a line that our graph cannot cross because there is no tangent of 90 degrees. Now let's scroll down some more. Now we go down, down, and down some more, and one more. There we go, and I'll pause right there because now we have 135 and minus 2. There's 135 minus 2 is down here. So let me plot that point. There it is. Okay, then 180 and 0, which is on the x-axis. There we go, and then 225 and 2, which is up here right there, and I'll plot that point as well. Okay, great. Now let's scroll down some more to go and find 270, 315 and 360, and I'll pause right there, and I'll move this video a little bit to the left here in between these sections so that I can just quickly draw the 270, 315 and 360. Okay, I can still see my y-axis there. So the 270, which has an error because there is no tangent function for 270. So again, I'm going to draw an asymptote right there. So it's basically the second cycle that just repeats itself a little bit later on. So it's the same as the 90 earlier on. Okay, so there is my asymptote, and then 315 will be minus 2, which is down here. Let me just plot that point in. There we go. And then the last one, 360, which is on the x-axis, and there is the dot as well. Okay, so we plotted all the coordinate points. So let me quickly put away my calculator here, and I'll move it here to the right. There it is, and now I can simply draw in my function. Now it's so important that you remember what the shape looks like. This is a positive function, so we start at 0, we will go up, but I need to go through that dot towards the asymptote and go up, 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 and don't cross it. So here we go. I go up, 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 and like that, and I didn't cross it. And then the next one starts at 180 and it goes down towards the same asymptote. So we go down through that dot, and there we go. Don't cross it. And then we do the same now again, because this is the first cycle. So this entire graph just needs to repeat itself the same way. So we start there, it goes up, and then the next one comes down again. So let me show you what this looks like. So we just start at 180, it goes up through that point, and it goes up like that. See, it's got exactly the same shape as our previous line there. And then this one needs to have the same shape as this line that I'm pointing to now. So let's do that from 360 all the way down, and there we go. And there we have two cycles of the tangent function. Now please remember, it does not have an amplitude. This value here simply tells us the value at 45 degrees. There we go. Also at 135 degrees, but just this time with a minus sign. Also at 225 degrees, there's the 2 again. Got it? And a normal tangent function that doesn't move up or down starts at the origin. That's how we can always spot whether a tangent function moved up or down. Okay, and that's basically how we draw a tangent function for the domain 0 to 360, even though the period is 180. So we just go and redraw this function one more time. So it's just 2 cycles in 360 degrees. Okay, so let's go and try some more. Now here are 2 more examples that we are going to try and draw just to get used to the tangent function. And our first one is minus tangent x for the domain 0 degrees to 360. Okay, so basically the tangent function will complete itself twice in that domain because the period is 180. So here we go. Let's just see how we will type this. We press the button mode, then 3 to access the table. We type in minus tangent alpha x, close the bracket, and then press equal. There is no gx, so just press equal again. We want to start at 0. We want to go and end at 360. Because it's a tangent function, our step is 45, and then we press equal, and there we go. So let me just move this calculator to the side so we can draw it. Our first coordinate pair is 0 and 0, so that is right here. And then we have 45 and minus 1, and then we have 90, which says an error, so basically that is where our asymptote will be. Okay, there it is. And there's also an asymptote at 270. We already know that because there is no tangent function for 90 and 270. Now let's quickly continue with our calculator here, and we're going to scroll it down a little bit. So go down, down, down. There's the 135, the 180, and 225. So let's quickly see. 135 and 1. And that means that we are going to, if I just move this calculator again to the right, so 135 and 1, which is up here, and I'll quickly draw that in. And again, I'm going to go a bit quicker. You can figure this out, how the coordinate pairs work throughout the video. And then 180 and 0, that's where it is. 225 and minus 1, which is right there, okay? And then we continue to scroll down. And let's go down, down, 270, 15, and there's the 360. Let's just move the calculator to the right again. And then we know 270 is an error. 315 will be a 1, which is up here. Let me just draw in that dot. There we go. And then 360 is a 0. Okay, got it? So there's the pairs. And I can quickly put away my calculator. And then we simply have to draw the function. Now again, this is a negative tangent function. So from the point where it starts, it goes down first towards the asymptote through this dot. There we go. And don't worry so much about the rest of these dots. And then the 181, we will start there and it goes up towards that asymptote. And then basically this entire cycle repeats itself one more time. So it must look exactly the same. So again, this one goes like this and down. And the 360 goes up like this and up. And there we go. We are done. Excellent, right? Okay, so how about the next function? We want to draw the tangent x minus 1. So it's a normal function that moved one place down. And again, we are going to need our calculator for that. So, and we want to draw it again from 0 to 360. So here we go. And there we go. We press the mode button. Then we press 3 to access our table. Then we press tangent alpha x minus 1. We start at 0. We end at 360 degrees. Press equal again. Our step for a tangent is 45. And then we press equal. And there is our table. So again, for the first pair, it's 0 and minus 1. So 0 on our x-axis, minus 1 on our y-axis. So that point will be right there. Okay, then our next point is 45 and 0, which is on the x-axis. There it is. 90 is an error because that is where the asymptote will be. And let's draw that in. There it is. And now we can continue to 135. So let's scroll down some more on our calculator. There we go. And down and down. And one more and another one. We can go one more. There we go. And let's pause it there. And then 135 is a minus 2, which will be down here. Let me plot that in. So that is where the dot is. And 180 is at minus 1, which is right there. And 225 is at 0. Then we also know that 270 has also an asymptote. So let's draw in that asymptote for 270. There we go. And all the way down. And now we can continue to scroll down on our calculator. And let's go down. And one more, and last one, there it is. And then we can see here that 315 is a minus 2, which will be here, and 360 is a minus 1. So let me put in those two dots. So there as well as there, and then I can put away my calculator because we did all the points that's necessary. And now I can just simply connect these dots with the correct shape. Now this is a positive tangent function. So from the point where we start, we're going to go up through that point towards the asymptote. There we go. Then we start at 180, go down towards the asymptote, and then from 180 we're going to go up towards the asymptote again, because this is now the start of the second cycle. And then here at 360 we go down again like that, and that is what the shape will look like. Okay, so this is the shape for a negative tangent function. This is the shape for a positive tangent function if we have to draw it from 0 to 360. What if we have to draw it from 0 to 720? It will just continue again with a cycle and another cycle. Okay, so there will be 4 cycles. So the graph will simply repeat itself for the entire domain for which we have to draw it. Okay, so what is the period of this tangent function? Well, the period for a tangent function is always 180 degrees, because it takes 180 degrees for an entire cycle to complete itself. Now for the next 180, the cycle just starts again. What is the maximum value? Well, a tangent function doesn't have a maximum. It keeps going up, and we can basically say that it can be infinity. What is the minimum function or the minimum value? It keeps going down, so we can say negative infinity. What is the amplitude? There is no amplitude. Okay. What is the range? Well, it does have a range. The y is an element of negative infinity all the way to infinity. There we go. And what is the domain? The domain for this function, remember, it's not the same as a period. It is the place where it starts way on the left and where does it finish on the right on my x-axis. So 0 to 360. And we can simply write here that it is 0 degrees to 360 degrees. Now let's see what it looks like for this bottom part. What is the period for this function? The period for a tangent function is always 180 degrees. The range, well, y is an element of negative infinity all the way to infinity. And what is the domain for this one? Well, it starts here on the left on the x-axis where the x is 0, and it goes all the way to 360. So we write here that x is an element of 0 degrees all the way to 360 degrees, and close the brackets. And it has to be these brackets that are closed because they include the 0 and the 360. See? And that is all there is to it. So hope to see you again next time. Work through these videos, keep practicing and keep drawing it so that you know how to draw these shapes, and see you next time. Bye. This is your host Richard T, and thank you for joining us. Please visit our website mathsa.co.za for free guided exam tutorials.